f of x is equal to minus x cubed plus 4x squared minus 6. Part A, show that the equation f of x equals 0 has a root between x equals 1 and x equals 2. So if I substitute 1 into my function, minus 1 cubed plus 4 times 1 squared minus 6 gives minus 3. Now substitute 2 into the function, so f of 2 is minus 2 cubed plus 4 times 2 squared minus 6, which gives 2. And we can see 1 is negative, 1's positive, so I'm going to write the sentence, a sign change in the continuous function so there must be a root in this interval, in the interval between 1 and 2. Part B. Show that the equation f of x is equal to 0 can be rewritten as that. So let me take my f of x function and make it equal to 0. Now I note that I want to be able to get a square root. So I want to, the step before having a square root is to have an x squared. So I'm going to rewrite this so that I can end up with that situation. So I am going to first of all take the 6 to the other side. So I can rewrite this function like that. I'm then going to factorise an x squared outside on the left-hand side. That's a good thing to do because that's going to give me this 4 minus x. And it's going to produce that x squared that I want. Now I can divide both sides by the 4 minus x. And then if I square root both sides, that takes me to the answer that I needed. Part C. Starting with x1 is equal to 1.5, use the iteration formula to calculate the values of x2, x3 and x4, giving all your answers to 4 decimal places. So to get x2, all I would do is I would substitute 1.5 into this iterative formula. And when I put that into my calculator, I find x2 is 1.5492 to 4 decimal places. Now to find x3, instead of substituting 1.5, I'm just going to use the answer button on my calculator now. In this same formula, so the square root of 6 divided by 4 minus the answer, and the calculator will automatically take my 1.5492 and use that in the next calculation, which gives me 1.5647. And I'll do that one more time, so just press equals one more time to get 1.569. Part D. Using a suitable interval, show that 1.572 is the root of f of x equals 0, correct 3 decimal places. So suitable interval is going to be the upper bound and the lower bound of 1.572. So the lower bound is 1.5715 and the upper bound is 1.5725. So if we show there's been a sign change in that interval, so if I substitute the 1.5715 into that original function, I get minus 0.002. If I substitute the upper bound into that original function, I get positive 0.0026. So, sign change. In the continuous function, so there must be a root in that interval. There must be a root between 1.5715 and 1.5725, and all numbers in this interval round to 1.572 to 3 decimal places.